Hello everyone. In the last video we saw how to create pie charts using geometry nodes. Today we will see another application of the arc node and create a measure angle tool using geometry nodes. The file we create is available on GitHub. You will find the link in video description. So let me pull up the geometry node editor window and create a new node tree. For measuring the angle we need two connected edges, so I'll first of all convert this cube into two connected edges. So I'll merge the top and bottom vertices. We got one single edge and I'll subdivide this edge. And so we now have two edges between which we can calculate and show the angle. We'll start with edge vertices node. It's in mesh, edge vertices. This will give us basically the vertices of individual edges based on the index. And to get the actual coordinate of the vertex, we will use the sample index node. I'll connect the geometry, the input geometry to this geometry socket and the position value to the value socket of sample index. First we'll get the vertices of the first edge, so I'll keep the index 0. Now we have here at this point the coordinate of the first vertex of the first edge. Now where exactly this coordinate is, to check that, let's add a UV sphere with small radius and let's set its translation to this position. So I'll add a transform attribute node and use this position as the translation of this transform, and let's check where that sphere is. Yeah, we need to change this to vector and this to edge. So that's this vertex. Basically this is our point 2, this is point 1 and this is point 3. Okay, so basically we got the point 2 position. I'll rename this point 2. We can minimize this. Next let's check the position. Let's first of all duplicate this sample index and again we will connect the geometry to the geometry socket and this time position 2 to value. We'll keep the index the same, 0. Let's check where this is. Obviously it will be point 1 because we are dealing with the first edge. So I'll rename this as point 1. We have now two coordinates, coordinates of two vertices. Let's check the third one. For the third one, we will need to set the index of the edge as 1 because we are dealing with the second edge now, and we want point 3. So let's check whether it's position 1 or position 2 of this edge. Yeah, it's actually position 1, so I'll rename this as point 3. Now we have these 3 coordinates of 3 points at these output sockets. I'll delete this UV sphere, we don't need it anymore. Now first of all let's create two lines connecting, representing these edges. So the lines are basically PT1 to PT2 and PT2 to PT3. I'll add a curve line, curve primitive, curve line, and let's have PT1 as start and PT2 as end. let's also have a join geometry node so that we can join both the lines. And if now I connect this to the geometry, this should give us the first line. Similarly, let's rename this line 1. Similarly, let's have line 2. For this, we will have point 2 as the starting point and point 3 as the end point. Let's connect this also. So now we have both the lines. Let's give some thickness to the lines. So I'll convert these lines to mesh, curve to mesh for both this as well as this. And we need a profile curve for which we can use a simple curve circle. And let's get the thickness from the group input. Initially we can set it to a small value, 0.01 let's say. So we'll just connect this to profile curve for this as well as this, both the curves. So now we have two lines now. Now let's create the arc that represents the angle, or that will display the angle. To calculate the angle between the vectors, we have a certain formula. Basically, there is a relationship between the angle between the vectors and their dot product. So before that, we need to first of all create the vectors representing these lines. Currently, we only have coordinates. So basically, the way we will get the vectors is we subtract the second point from the first point. So we want vectors like, our first vector will be this one and the second vector will be this one. Okay, so for V1 we need to subtract PT2 from PT1. So PT1 minus PT2, and this vector 2 will be PT3 minus PT2. So let's get these two vectors now. We already have PT1, PT2, PT3. So I'll just add subtract nodes, vector subtract PT2 from PT1. This is our vector 1, V1. Similarly, if I subtract PT2 from PT3, and duplicate this node, and let's subtract PT2 from PT3. This will be our vector 2. Basically, the way we calculate the angle between these vectors is, let's say this angle is theta. So the relationship is V1 dot V2 is equal to length of V1 multiplied by length of V2 into cos theta. That is the angle between the two. So this means that theta will be V1 dot V2 divided by length of V1 into length of V2 and the cos inverse of this entire thing. So let's get these nodes. Actually, we have two vectors. So let's first get the dot product of the vectors. This will be our dot product, and then we need to get lengths of individual vectors. So I'll add a vector length node for V1 as well as for V2, and let's multiply these two lengths. Remember, these dot product as well as length, these are all scalar quantities. That means they are simple floats, not vectors. So we need just multiply math node. So once we multiply these two values, we need to divide the dot product with them. So let's have a math divide node and divide the dot product with the multiplication of the lengths. Now we can take the arc cosine of this result, and here is our angle. This is basically our angle. So we can group these nodes. call this group angle. So this actually represents the angle between these two vectors. Let's first display this angle using string to curves node. So I'll add a string to curves node. We have the angle, so we'll first of all convert this to string. So we have value to string node. This will give us angle in radians. We need to convert this angle into degrees. So let's add a math node to 2 degrees. So this value we will feed to, I'm sorry, not this one. This value we will feed to 2 degrees, and degrees value we will give to the value to string node. We can have multiple decimal values, but I'll for now keep it just the degrees without any decimal digits. And let's give this value as the string input to a string to curves node. And we can join this to join geometry. So we have actually now the angle between these two edges. I'll set a smaller value for this, smaller size. If I change the location of these points, this value will change. Let's also put a fill curve node so we will be able to see the values more clearly. The next thing we want to do is basically show an arc like this one between these two edges. So I'll right away add a curve primitive arc and connect it to join geometry. This is our basic arc. We know that the sweep angle determines the end point, and we already have calculated the angle. The sweep angle is in that we will be feeding will be in radians. So I'll connect this to the sweep angle socket. This is actually representing 92 degrees. But the thing is that the center of it, we should be shifting it to this point, that is point 2. So I'll add a transform node. Set the translation to point 2. We already have point 2, so I just connect this point 2 to translation, and we have the curve here. But the point now is it starts at this point, that is parallel to x-axis. So we want to align this particular arc to V1. So let me add an align Euler to vector node. And we have the vector V1 calculated already. So I'll give this vector V as the into the vector socket, and we can simply rotate this arc by this angle. So now you see that the arc is actually placed the right way. Let's also add a curve to mesh for this arc also. We have this curve to mesh, and we need to give it the profile circle. So we'll have some thickness. Let's connect this to rotation. Yeah. So now we have the right rotation, but the problem is now if you look in 3D, in 2D this will work fine because we are dealing with a flat plane. But in 3D, if I shift this point along, let's say Z, this curve is not connected to that particular line. So we need to basically align this curve so that it's in line with the plane forming these two edges. The way we do that is basically we calculate the normal of these two edges, and the normal is calculated by using the cross product. So if we have these two vectors v1 and v2, we take the cross product, and the cross product will be actually the normal, which will be perpendicular to these two vectors, and we need to shift this curve, shift the alignment, rotation of this curve in that particular direction, the direction of the normal. Okay, so let's do that. So first of all, we need to take the cross product of these two vectors. So I'll add a cross product node and take the cross product of these two vectors. And we need another align Euler to vector node so that we can convert this cross product vector into rotation. And we are rotating basically in the direction of Z. So I'll use the axis as Z and then feed this rotation to this value. And you see that now we have the right rotation even in 3D. And the last thing that we want to do is to place this text properly above this arc. But before that, let's get the radius of the arc also from the group input. The first radius is actually the thickness of the lines, and the second radius is the arc radius. So we can change the arc radius from the group input. Now we want to place this text above this arc in the same plane as the vectors and the arc. First, let's translate the text to the proper position. So we'll place the text along this vector, which is in the middle of these two. So if this is our V1 and this is our V2, if we normalize V1 and V2, by normalizing we get a vector along the same direction with unit length. So this is a normalized V1 and this is normalized V2. And if we add these two vectors, we get a vector in the middle of them. So this is basically the addition of V1 and V2, normalized vectors. So we will place the text along this vector. We will first normalize this vector so we get a unit length vector along this, and then scale it with the radius value. So we'll get a point here on that curve, and we can further offset that point and place our text there. So I'll first add the two vectors. So I'll add a vector add node and add V1 and V2. But before that we need to normalize them. So let me add a vector math normalize node for both V1 as well as V2. So now at this point we have this resulting vector. We will normalize it again. So we have a unit vector along this, and then we will scale it further by the radius amount. We already have the radius in group input. So I'll get this radius and plug it into the other socket of scale. Now here we have got the point location here, but still it is not exactly here because we are doing the calculation from origin. We want to shift that origin to the point P2. So we need to add again P2 to this. So I'll add a vector math add node and plug in the P2 value in the second socket. So now we have got a point here, and we can translate the curve representing the strings with that value. Now basically we need to align this string properly in the middle and center. Now we have the text at the right position. Now if we want, we can further offset this along the same vector. For that we can take another input from group input and add it to the radius before we scale the middle vector. So let me get another input. Let's call this text offset, and instead of scaling this with this one, we'll scale it with the resulting value. So with this value we can control how far the text is from the curve. I'll also reduce the size of this string, let's say 0.3 or so. Now we have the text at the right location, but its rotation is not correct still. We want to bring it in the same plane as these two vectors. We already have the rotation for that, which we used for the arc. We can use the same rotation Let's try doing that. So if I now plug the same rotation to the text, it will get rotated and it will be in the same plane. But the thing is, it is now aligned with this. We want it to be aligned with the resultant vector, that is the middle vector. So what I'll do is, I'll basically duplicate this align to vector node, and instead of aligning it with V1, we will align this with this normalized resultant vector. The rotation will be the same, so we'll get it in the plane of the vectors, and I'll plug in this value in the rotation socket. We can rotate it along Y so that it is in the right orientation. So we have actually now the text in the right place, and that pretty much concludes this tutorial of creating angle measurement node. Thanks for watching. If you have any queries or suggestions, please leave a comment on this video.